Computing definite integrals using Riemann sums. Before we start, here is the standard form of definite integrals. The antiderivative of f of x, where limits from b to a, where a is lesser than b. Here is the first example. The antiderivative of 2x squared plus 5x minus 7 dx, where limits from negative 1 to 4. First, give the antiderivative of the given function. 2x squared plus 1 over 3 plus 5x 1 plus 1 over 2 minus 7. So, the antiderivative of the given function is 2x cubed over 3 plus 5x squared over 2 minus 7x, which has a negative 1 lower limit and 4 upper limit. After getting the antiderivative of the given function, substitute the given limits, where 2 4 cubed over 3 plus 5 times 4 square over 2 minus 7 times 4, and then the other limit minus 2 times negative 1 cubed over 3 plus 5 times negative 1 square over 2 minus 7 times negative 1. After substituting the limits of the given function, which is for area, we get 45.84 square units.
In the first example, the limits are given. But what if the limits are unknown? In this example, find the area between the curve, which is x is equal to negative y squared plus y plus 2, and the y-axis. Since the given curve is the parabola to the x-axis, we first calculate its y-intercepts by setting or substituting x to 0 to determine the limits of integration. Next is illustrate the curve to easily calculate the area of the given function. Since we already know the limits of the function, we can now get the definite integral of the function. The antiderivative of negative y squared plus y plus 2 with the limits of negative 1 to 2. Here is the antiderivative of the function, negative y cubed over 3 plus y squared over 2 plus 2y with the limits of negative 1 to 2. After having the antiderivative, we should now substitute the limits of the function. negative 2 cubed over 3 plus 2 squared over 2 plus 2 times 2, and the next limit is minus negative of negative 1 cubed over 3 plus negative 1 squared over 2 plus negative 1 times 2. After substituting, we can get the area of the function, which is equal to 4.5 square units.
So that's the end of our video.
For computing the definite integral using Riemann sums.
Bye!